go check it on another computer.
A imamo mic? Imamo? Okej.
Please sit down.
Sam mi ga ne bomo slišali.
Se tudi na ozvočenje.
Okej.
A ga ni? Kaj pa ta drž, profesor?
Ja,
Sem basla. A pa ga ne bi mogli? Dajte ugasen drž, no. A ja, ker je to full mod mic.
kaj pa če bi dali k sem? Kakaj te tam male?
Kaj?
Yamahe? Yamahe?
Ne, problem je, da je wireless mic in da imamo direktno zvočni kartico. Lahko si pa na mobitelu streamaš, pa da se šlanci.
Ne smem. A je ta metla v kadru? A je metla v kadru? A ga lahko ne? Ne, no. Če bi še drvarnica. A lahko zdaj PIFcamp plakat
Večino je
damo?
full close-up, le pogledaj, kako se
Pa
kaže.
če damo plakat tam.
Samo totalo je videti metla.
A je umaknil? Ni čilo. A ga dam? A se začnemo? Čas?
Moja mama še čas.
Kje pa so se?
Ena kamera več koristi.
Please, come and sit. Right? The oscilloscope. So, time. Okay, it's 8. Do this.
Do we have a minute?
No, nothing now. What do you want? Yeah, do it.
Pazite in kamero.
Sam pa, da Jurek, kam ga dam?
Ja, zadaj sem, ne vem, če se bo na steno poljil.
Kaj pa ne?
We can have a rain effect, like you can.
Now the
Really rain effect.
This is the countdown.
it's right behind this.
Yeah, yeah. More to the right. More. Okay, like that.
Roman, a tako na malo.
Ja. Skala je.
Zdaj so modularci.
Switch the camera and the sound.
Ne, čist mečkam več mogoče, ker so modularci, se ne vidi dobro. Čist malo. Tako je. A je v redu na tvoji strani?
Okay, so I'm turning down the ambient lights and turning up.
Ready? So as soon as you switch the camera, it will start. Hello, this is Václav from Basto. This is my very good friend Bernhard. We are at PIFcamp in Socha Valley in Slovenia with a lot of lovely people, and we're doing this lecture mainly for them. So they're sitting right here. So Bernhard will do an introduction to oscilloscopes, and he has an amazing laser projector performance where he connects light and sound, and it's really fascinating and amazing. So you should check out the BRLaser live act, and we also perform together sometimes as the Laser Bros, and Bernhard also has a lot more projects. So yeah, I hope you enjoyed the next hour with Bernhard and learned something new about oscilloscopes, vectors and modulars. Now to you, Bernhard.
Thank you, Václav, for the introduction. Welcome, everyone. Yeah. Thanks for coming. There's some more seats here if anybody wants to sit. If I don't talk loud enough, just let me know. And I try to be as thorough as I can and try to be very basic. So the oscilloscope is a device that is actually an ancient device. It has become obsolete in this form. This is an analog oscilloscope with an electron tube, it's called CRT, like a cathode ray tube. And what it does, or what it means, like the oscilloscope, if you take apart the name, like oscillare means to swing, and to scope means to actually see something. So you can see the swing of signals, or it was used as test equipment in electronic laboratories in the past to troubleshoot or to design circuits. And it has become obsolete in this form because on the market digital oscilloscopes have taken over the world somehow. And so this is kind of, I think this is from the late 70s. And it has a tube inside, so it shoots an electron beam from the back. There's an electron gun. It shoots a dot or a beam to this little screen, and then you can, depending on what you connect to the inputs of the scope, you can look at waveforms of signals and look at voltages. And basically, maybe we turn this on. And also, I have to say that these machines can be very intimidating because they have a lot of knobs, and but it's really very simple. If you know, I'll try to explain what everything does, and so you can, if you ever encounter a scope, you can, maybe measure something with it, or also just play. Like I use this to look at modular synthesizer waves and connect the modular synthesizer, and to understand what the modular synthesizer does better. And also you can look at sound waves, or like speakers, signals that go to the speakers, and so you can somehow look at signals that you can hear through speakers and understand sound in a better way. Like this synthesizer sound is we can look at some waveforms. But let's start with the oscilloscope, and we'll turn it on. It has a switch here that says power and scale illumination. And if you switch it on, this is an old device. It needs a little bit to warm up, and then if it's working, like this is a used one that I bought secondhand, you should see some lines appear. So the electron gun is shooting a dot. So we turn this down, and so there's the single dot, and then this single dot is just a beam being shot at the screen, which is the main device to display the signals. And what we can do with this dot, there are some electromagnetic plates inside here, and we can put voltage signals, apply these voltage signals to these plates, and depending on which voltages we send to these plates, this dot will move back and forth, or will move up and down, because there are plates on the side here and plates on the bottom. So you can deflect the beam that goes from the back of the tube and hits the front of the screen. So you can get vector shapes depending on the signals you send into the oscilloscope. For that reason, the scope has two inputs. So this is a 2-channel oscilloscope. So there are 2 inputs, and the inputs are these funny little connectors. They are called BNC connectors. And usually, like if you were in a electronic lab, you would have these probes that you can poke on like PCB boards, and the other side you would connect to, like this is channel A, let's connect this to channel A, and then you have one big dial which basically allows you to scale the signal, and if you turn this knob and you just touch it, there will be a static voltage that my body induces into the system, and we can look at this just by me touching it. So that way you can see if this oscilloscope works. And of course there's another channel, this channel 2. We can do the same way. There's then a mode switch to see which channel is being displayed. I press channel 2. And because now we are in a mode called X and Y, the channel 2, it also says here there's channel 1 or Y, or channel X, channel 2 and X is being deflected, is being sent to the other side of to the other plate. That's, you know, this channel now is connected to the plates that go that do the horizontal deflection. And if I change it back, this is sending the signal to the plates of the vertical deflection. So there are two input channels that you can connect signals into. There's also a if you want to look at signals on a time base, so like over time, there's something like a sweep time knob, and so it's like a function generator that creates a linear voltage, and that is applied to the horizontal deflection plates, and it's automatic. And with this dial called sweep time, you can speed this up, and what happens is the dot will go in a linear fashion, will go over to this side of the screen, and when it reaches this, it will fly back very fast, but it's blank, so you don't see the retrace. And so if you speed this up, at some point the dot will move so fast that you will see a basic line. And then, because we have chosen channel 1, there's also a switch or a knob that lets you position the line depending. There's a grid, and back in the days this was used to measure signals. So you could align the zero line or the reference line to the grid, or like set it off, but we'll align it now on the really middle, and then we'll do the same with the second channel. There's also a position knob here. So there are two function blocks, with channel 1 with a position knob, and there's channel 2 with the position knob, and there's also a little switch here that allows you to decide the coupling of the signal that you want to send. Like if you want to measure signals that change the polarity, you put it into like AC, alternating current position, or if you want to look at signals that are direct current that have only one polarity, you put it into DC. We'll leave it into DC because then we can play around with positions, and it doesn't like always pull the image into the middle. And then here we have a mode selector, and because this is a 2-channel oscilloscope, we can actually display 2 lines, and then we have the mode alternating or chop. So we have 2 lines for each channel is deflected by 2 lines. Now we are in the sweep time, so we are being displayed, the display is showing a continuous display over time, which is like linear, and so this is channel 1 and channel 2. Then there are some utility knobs like focus. You can focus the beam, and intensity. You can make things like dimmer and stronger. And then there's a part. It's a trigger section. We'll move to that later when we connect some signals. But I'll put away the probe. This is the probe to probe signal, and I have a cable that also has a BNC connector. And for this demonstration, I've chosen two devices which actually can be intimidating both at the same, but then together, because they look very complex. They have a lot of knobs. Or this is a modular synthesizer, and some, often if you don't know what it is, or if you have never used it before, it can be super intimidating because it says funny things. And but I've chosen this one because it's mostly from a manufacturer called Töpfer, which was the founder of this format, the Eurorex synthesizer, modular synthesizer. And so you have a frame with different functions inside. And what is very good about this system, it is very explanatory. So it always, it has it always explains at the top. It gives you the name of the module of the function, and then with all the knobs, it will tell you what it is, and also it has little signs and designators. You see little waves, and that's what we actually want to look at, waves or signals on the oscilloscope. So we'll just go ahead. I have a cable here that has a BNC connector on one side. We'll plug this into channel 1, and then we'll split the signal. We have one cable. And now we'll do something. We'll look at the waveforms and we'll listen to them at the same time. So there's one function in this system that is connected to the PA system, and we'll make a split cable and put this into the PA system, and also put the oscilloscope channel 1 into this. And now I have a kind of a hot wire. So wherever I go, and which jack I would touch, we will see on the screen, and potentially we should also hear the sound. But maybe I have to turn it up. So now I will adjust the amplification, and here I've plugged this cable into a jack that it makes a triangle wave, and we can see the triangle wave, and then we can now just play with this function. So now nothing is connected on the synthesizer but this function, and if we can change the pitch of this wave, so the frequency changes. You can see on the scope that the wavelength gets wider and the pitch gets higher and lower. So there's different. You can have this. The waveforms can have, or the signals can have different characteristics. Like for example, pitch, which is kind of the frequency of the wave. And it can also, now if we look at another waveform, for example a sine wave, sounds very similar to the triangle wave. Has the same frequency because it's from the same oscillator. It has a little bit of different timbre. If we look at a sawtooth wave, it is a wave that has a very sharp edge, and you can also hear this very sharp edge. It has a higher harmonic content in the harmonic spectrum. And then let's look at another waveform. It's called a pulse wave or a square wave, which sounds different again. And you can change the width of the pulse with this knob here. So this function, this basic function is called an oscillator. It also says here at the top, it's an oscillator. It will give you waveforms that swing back and forth, and if they do this with audio rate, you can hear it, because this is a sound device or a device to make sound with. And so there are a couple of functions, and if you look at, so you can go around with the hot wire, you can probe different and see what all of these checks do. Of course, if you plug this into, like, there are input and output checks, and if you plug this into an input, nothing will happen, because, let's try this, because there's nothing coming out. So we only can look at waves that come out of the system, and then we connect into the oscilloscope and then go to the speakers. And so the synthesizer has different functions, and I will there's so I mentioned before that you have like the waveforms can have certain qualities. For example, the pitch, which equals to the frequency, and then there's also a quality which is, for example, the loudness. And we can control the loudness. There's like a function here. It's called an amplifier. And if we take this, like we plug the hot wire into the output of an amplifier, there's already something pre-wired, and into the input of this amplifier we plug, for example, this sawtooth wave. And then with the amplifier we can control the loudness of this signal by turning this knob. And then now what we have done, now we have connected two cables. Like one cable is like the oscillator is going into the amplifier is going to the output module and to the oscilloscope. That makes it listenable and also like seeable, or like seeable. No? And so and what is a cool feature about this synthesizer is that you can turn knobs with your hand manually, but you can also do something which is called voltage control. Like often there's like a term that says VC, which means voltage control, A for amplifier. And what that means is if you, there's like CV inputs, CV means control voltage, and then if we plug a control voltage into this input and, for example, took a signal, a sine signal that is coming from this low frequency oscillator and opened up the modulation, then this oscillator will start to open the amplifier for us instead of like manually opening and closing the amplifier. So we can automate. You can automate the movement of these knobs, and then you can speed it up. Actually, we can also visualize, because we have a second channel on the scope, which is the second line. We could visualize the low frequency oscillator going up and down, and whenever it passes the zero line, it will open up the amplifier, and then you would see that the signal gets amplified. So let's take another output, the similar output from this, and adjust the range. So you see now the line goes up and down, in a linear fashion, and whenever it passes the 0 line, or maybe it will open up. It can only open up the amplifier if it's a positive voltage, because this amplifier, this particular one, can only take positive control voltages. And so I've set this system up to so this is like 2 or 3 functions that we're looking at now, and like function by function, like you know, it's hopefully it's you can then maybe start to use this system yourself, and also you know, there's no reason to be afraid to do anything wrong, because you can't, you know, you can connect whatever you want. It can't explode or anything, or you know, it won't burn. Maybe the worst that can happen is that you don't hear anything. But because it's so descriptive, it says like inputs and outputs, and if you usually connect an output to an input, something will happen according to like, of course, according to what you have connected together. So these modules talk together by connecting them. And so let's look at another module, which is maybe a filter. And now we have this. So now we can make things louder, and we can change, which is changing the amplitude or changing the loudness of the signal. But also we can change the timbre of the waveform, which kind of changes the color. Like we've tested different. So this has another tonal color and tonal quality than a sawtooth, then a triangle wave. But let's stick to this. Let's stick to this sawtooth wave and change the color of this tone by going through a filter. So now we have 3 cables. We unplug the output that actually shows us on the screen what we want to hear and listen, and we connect this to the output of the filter, which is a low pass filter, and it's this black module here. And then of course we also need the inputs, and we take another cable and go from the output of the amplifier into the input of the filter. And then by applying the filter we can take out harmonic content. So now the filter, we can make the filter rounder, or the sound rounder. We can take out harmonic content. This is a low pass filter, so it will let low parts of the harmonic frequency spectrum pass through the filter, and the high frequencies that really build these edges. Let's stop this modulation for a minute and make a static wave. And so if I turn the filter has like a frequency cutoff control, which defines the frequency where this harmonic spectrum is being cut. And if I apply the filter, it will only let through the low pass, and I will end up with the fundamental wave of the initial oscillator. And then there's also something very nice, which is this filter can also self-resonate. If I turn on the resonance and apply the filter again, you would hear a resonant filter sweep. And you can also see the resonance on the screen and see what the resonance does. It just starts to, as you can see, the oscillation of the filter being modulated onto the wave that it's filtering. Here we have the fundamental again. and it changes the tonal color of the initial wave. This is very classic synthesizer resonant filter sweep synthesizer sound. And if we take another cable to automate, for example, the frequency control, because this is also a voltage controlled filter, which is very handy about this modular synthesizer. So there is an input saying CV control voltage for the frequency knob. So I don't have to turn this back and forth. I will take another oscillator here and automate this parameter. Now this is being controlled by another oscillator, and I can speed this modulation up. And just look at the screen, for example, and then now I have already like 4 modules, 4 elements connected, and if I change the knobs on these elements, I can kind of play a visual show with this and also listen at the sound at the same time. But for me personally, this was quite a revelation to be able to see what you hear, and then why the sound from the speaker sounds like this, and to see a representation of the sound or how the cone moves back and forth. And the oscilloscope is the tool that could do this trick. And yeah, we can. I can only encourage to. Let's take this out again. I can only encourage to not be afraid of a modular synthesizer. Of course, it's a very personal. Like, you can assemble this in your own way if you have one. There's also digital modular synthesizers or emulations of these synthesizers online, because they also cost money. And but this Töpfer synthesizer is very basic functions that are quite easy to use, and you can build up the synthesizer that you want. I built this synthesizer for demonstration purposes, and hopefully people here will use it. Like, I want to keep this setup, and we'll put some cables and play. And Václav is also here. He is a synthesizer designer, so if you have questions about, or if you're stuck with it, you can always ask me, or maybe also Václav. And it's a very interesting instrument to explore. So you can go. So now we've kind of have a static wave. We've animated the wave. We kind of made some quirky sounds with it. We can change the color of the sound by applying filter and resonance in the filter. Being automated. We can also apply the amplifier, so it can go silent and be louder again. And then if we, for example, take a waveform that will turn the amplifier on and off like a square wave to turn on the amplifier, we can make some kind of rhythm with this. And then we have, like, now we have three oscillators. One oscillator is making the basic tone. One oscillator is controlling the amplifier and turning the signal on and off. And the third is animating the filter, is animating the color of the tone. And if you tune things, now you can start to play with just turn knobs and create rhythms. Or you can then you can try to play melodies. You can try another waveform, another color. And there's also another module down here on the side, which is a reverb module. I've pre-connected it to the output, and I will take into the input. I will take the output from the filter. Oh, sorry, I will turn this down and apply a little reverb. So the sound also changes, and then let's stop this for a moment. So with very simple functions, we have kind of made the rhythm. We've changed the color of the tone. We've changed just with like very few cables. I think we have like 4 cables or 5 cables maybe. And of course you can go crazy with this. You can just patch anything, but always remember that if a function is not connected, it won't do anything. And always be sure to read the function. Then like there are some terms which need explanation, like a VCO is like a voltage controlled oscillator, and if you don't know what it is, of course it's really hard to understand. But so be sure to ask questions if you have them, and I think for now it's a good system, or it's just good to try out yourself. Don't be afraid to patch. There's nothing you can break, and just it's a very nice instrument to. Actually, I have a good friend who asked me about. He's a drummer, and he's classically trained as a drummer, and he earns his living and by drumming. And he said he has to read sheet music and play from and make no mistakes and play music that somebody else created or wrote, and it's not a very creative process. He said he studied drums, and somehow he's he lacks, or he started getting into modular synthesis in order to somehow find a creative musical approach again. And then we spent a little while together, and he said, I kind of have an idea and I have to follow this idea, but I don't know how can I work with this creatively. And for me, the trick was looking at the waveforms to understand the synthesizer. I also started at some point and had no clue what this machine was. And then I met people on the way that explained things to me, and I watched online tutorials. But the main trick, or the major breakthrough for me, was to really see the waveforms and to hear them at the same time, so I could understand them better, because we are visual beings, and this is actually to finish the story with my friend who is a drummer. It's actually a good instrument to unlearn, maybe, or to learn. To unlearn is hardly put. To unlearn musical skills that you have maybe been trained to, and find creativity again just by playing like a child, or just turning knobs and connecting output jacks. Even you might not know what you're doing, but you can you can't do anything wrong. You can connect inputs to outputs. You can do feedback loops. You can go, you can think up something, but you don't have to understand the machine in order to use it. You can just, like these cables and like the colors of the cables and just explore and go crazy. And it's sometimes it's hard to do because like we humans, we want to understand, of course, like how this works, and then once you start to learn how things work, then you start to fall into certain patterns and grids and in structures, and it's really hard to lose these structures again. And then the more you learn, so this is a very good unlearning tool, and I can only encourage to like play with it, have a playful approach like a child, and like don't be afraid, like be curious about it. Be sure to ask questions if you have any about like specific modules, maybe if they are not explained on the faceplate, and if something is unclear. There are some modules which are more special or like may not be like so intuitive at first, but there's always you can just plug a cable and see what it does, and look at the scope, and maybe explore this way, and be curious about, and so this is the basic introduction, and I hope like I will leave this setup. I don't know if we leave it here or we put it somewhere else for people to play. Are we on the time? We can.
You can also explain the XY, how you do the shapes.
That's a very good idea. This scope has 2 channels, and now like if you look at waveforms on a linear time domain, it will always be represented like a line, and then the deflection of the wave. Let me just find the hot wire again, which is this one. So let's see. We have a circle here. We have a sine wave here. We speed up this circle. This sine. So you will see a sine wave if you deflect this sine wave, or if you take the sine wave apart on a linear time scale, because one of the axes or one of the magnetic deflection systems is now being controlled by this linear function that goes from one side to another. It's like a ramp, and then it jumps back, and then it ramps up again and jumps back. So that's a linear function. But you can apply another function. So there's a mode switch here that says X and Y, and then the second channel becomes the second input, or becomes the input for another function. And let's see what we have connected here. So we can take out this jack, and if we connected another wave, a cosine wave, for example, we can draw a circle. So now we see the same waveform that we did before, but not on a linear deflection as a function, but on a circular function. So we can draw a circle, because what we are doing is we're just deflecting the electron beam with these deflection plates. And I use this principle, or this is now the mode called X and Y. So you have a horizontal deflection system and a vertical deflection system, and you're independent of the time base. You can draw like phase relations of 2 signals. There's always 2 signals involved, X and Y, or left and right, or in this case it's sine wave and cosine wave that make a circle. And we could potentially, like we can move this into the middle, and we can play the same trick now with this circle. We can make the circle bigger and smaller by, for example, taking the same amplifier and putting the second wave into the amplifier, and then this goes directly. Let me just replug this a little bit. This is here, this is here, and this is actually pre-patched, which I forgot. So now we have a size control over the circle, because we are controlling two amplifiers of the two signals at the same time with the same turn of a knob. And then if we, for example, modulated the same amplifier that controls two channels at the same time, we can, we had this low frequency oscillator, and we can take that as a control voltage and then turn the circle on and off, but there's an offset. So now it's, it sounds like a like a telephone somehow, like that is not answering, and then we can speed this up. So nobody's picking up the phone, and but we can change this to another shape. And then create different shapes just in a different mode that are expanding out of the middle, and they're not on a linear time domain. And for this you need access to two channels of the scope, or you could also do this on a laser system, where we have there's a laser here, and it's basically the same principle, only there's no electron beam deflected, but like a laser beam, which also makes a dot with two mirrors. But the principle is the same, X and Y, and yeah, so we can maybe create some spirals, tune the spirals, or just play around. Maybe we make some mandala shapes or some flowers. Spin the flowers back and forth. You can visually tune the oscillators together that are modulating. You can expand the flower. You can play with the shape, and maybe don't listen to the sound so much anymore. But that's usually what I do. I look at the picture and enjoy the picture, and just turn the knobs, and often I don't know what I'm doing, but this way happy accidents can occur, and sometimes you learn something new by making a mistake, or by having something that is out of your way of thinking. And if you allow these happy accidents, or if you allow these I wouldn't necessarily call them failures, but just playing around, and then you find new shapes, or you can find new tones maybe, and so we can, I don't know, what can we do? We can cross modulate something. We can take a reset. This is we can try to reset something in here. This is not the cross modulation. Let's see what happens if we do this. So now we get a circular, we get like another circle in the middle, but the tone maybe is not so nice. Or you get like a flowery shape like this.
It's almost an end.
Yeah. This is the end.
Maybe you can lick it.
I can what?
You can lick it.
Also, this is half legal. Yeah. This is, you have to be careful not to make any swastikas with this. But sometimes they appear because you mix the wrong waves. Ah, this is nicer. So if you tune things in certain ratios, you get certain circular divisions, and yeah, you can create like very nice flower patterns, for example, with circles. So you can mix two circles together with a mixer. There's also modules that we didn't look at today, but I'm sure like we can go through them, or you can explore them or ask about them. And yeah, I will conclude here. I hope you enjoyed. Also, stay curious, and don't be afraid to patch, and you know, be curious like a child. I can say this is an instrument that allows this kind of thing. It's very haptic. You can touch things. You can like play with the cables. I really like cables, so this is and here you have the opportunity to look and see at the same time. And yeah, we'll set this up for everybody to play. And also here, be sure to take headphones. Like if you have headphones, there's a headphone output I can show you, and then or we can also like operate it over the PA system. But maybe to explore, it's good to use it with the headphones. And yeah, this was it. Thanks for attending, and
Questions maybe?
yeah, maybe you have questions, and or it's
When you normally explore sounds, you are using like the both X and Y, or do you usually just use like the two like parallel signals?
well, when I started before I did the laser thing, I actually did the parallel parallel beams, because I didn't know of the X and Y modes. But then I could see, for example, I could see the resonances of the filter, and I could see the waveforms. And then over time, I got interested more and more, and I watched a video by Cherubim Fenderson, who draws the mushroom on the oscilloscope, and he explained how to draw a circle. And it was like, you have actually two deflection entities. So if you apply signals that have a phase relationship to each other, then and then since then I started using this X and Y mode more and more. But at first I was, it's just a different way, a different perspective at looking at these waveforms. It's on one side it's on a linear time base, so it's easy to understand on a linear function. And on the other side is everything, derives out of a center maybe. Like if you think about this circular thing, or like the deflection, because it's like a coordinate system, like a Cartesian coordinate system, which actually everything comes out of the center point, and this expands from the center. So it's just a different way to look at these signals, but the same signals can look depending on the time base, or depending on the perspective that you look at them, look differently. But still, a circle, or the function of the linear function of a circle is the sine wave. So they they kind of go together. It's just looking at the sine, or looking at the circle in a different way on a linear scale, and then you see the sign. So, but I've decided, I've really somehow found the XY mode very interesting for myself, because I like this idea out of the center, or like, and then you can apply different kind of techniques with the amplitude modulation, where things become bigger and smaller, and you can get these kind of zooming effects if you do it right, and so you can twist things back and forth, and yeah, this is X and Y mode is somehow the way to go for me. And
Are there any differences when using laser projector and oscilloscope? Like when making patterns, can you practice your show on this and then just go to laser projector?
I can.
Can you repeat the question?
Also yes. So the question is if I can, if there's a difference between the laser projector and the oscilloscope, and if I could practice the show or like patches on the scope. To some point I can, but the oscilloscope has is moving an electron beam, and the electrons hardly have any weight in comparison to the deflection system of the laser, which is two mirrors moving, and they're really small. As it's a mechanical system, these mirrors are very small, but at certain speeds, if you like deflect them back and forth very fast, they become very inert and they become quite heavy, and so you're limited in the bandwidth of the system, or just the deflection system can't go as fast as this system, or like the oscilloscope can like project much higher frequencies. The edges are much rounder, so you're kind of limited. Like I could potentially practice this, but then if I did the same patch on the laser, the edges wouldn't be so nice, and so I can kind of get the idea, but then I have to think like in terms of lower frequencies, and then things might work again. So I'm limited in the laser using different frequencies.
Thank you.
And also the laser can be more lasers, right? With more colors.
Yeah, exactly. The laser can be, or the laser beam can be composed of different colors, and you can mix these colors, so you can have like red, green, and blue, and like RGB show lasers, and then you mix them, and you can get a white beam. And here you can only like see this green, or this phosphoric surface on the screen makes the beam appear green, and so the color is kind of fixed. But on the laser you can play with the colors, you can modulate the colors, you can take out information from the system, and go crazy with the colors, and then people will ask how to make the colors.
How do you make the colors?
It's like well,
With the color of the cable.
with the color of the cable. So here's a green cable. So if the signal goes through the cable, then the signal is being colored green. So that's why it's easy. It's easy as that.
Just don't use the black cable.
Yeah. Well, if the black cable this cable goes to the colors,
That's always dangerous. Right?
you will see nothing.
Perfectly black. It just makes it a little darker.
Yeah. Super.
Bernhard, can I ask you, since we have this setup,
Yeah.
can you make the hard patch?
Yes. This is a story that's actually a patch that Václav showed me, who is very good at playing with oscilloscopes and also likes oscilloscopes. For that reason, I will comply. So the hard is a patch. You take a sawtooth wave and put it into the wasp filter, into the audio input of the wasp filter, and then you listen to. So we have the hot wire. We listen to this, and the other one goes here. No, maybe the other way around, because then we're upside down. And then it has to be a certain frequency range. Here you have to say the octave switch has to be on +2. Sawtooth going into the filter. You crank the lever, you put the resonance on full, and then you have to just find, it's a very fine sweet spot. I hope I can get it now. Let's hope for it. It's quite of an unstable spot. Maybe I have to tune it a bit higher. So there's a singularity of the filter. By the way, Václav, did you know that resonant multimode filters have a 90-degree phase output, phase shift output between the outputs?
I heard about it.
Yeah. And there was the heart almost. It's a tricky one. But give me another. So let's conclude with this. Share the love, share the love into the world, and thanks for joining. And be curious about the synthesizer. Please don't be afraid to touch it, play with it, ask questions, and I'm really happy that I could show you some insight, and yeah, happy to be here.
Thank you so much, Bernhard.
Thank you. Woo! Thanks.
Thank you so much for tuning in, and thanks, Bernhard, and yeah, be safe. Ciao.
Ciao.
The rain almost stopped.
Yeah, the rain stopped. I lost.